And welcome to Livestreams. Hey, am I talking to anyone? Is there anyone there? But anyways, hi, welcome to Livestreams. My name is Viktor Gamov, and I am a developer advocate here at Confluent. And Livestreams is a weekly show where I am streaming some of the cool pieces, technologies related to event streams and the Kafka streams or any type of stream processing. And yeah, I'm really to welcome everyone who is in chat. So let me check who is here, and let's see how it goes. All right. So we do have already a few people. I do see some familiar names. Let me open up this. Let me open up this YouTube, and I'll see. All right. Suraf. Ready, waiting for this. Welcome to Livestreams. Thank you for being with us. What's the OKC? What's the OKC? Let me know. So we do have Sarkrishna from Hyderabad. I'm sorry. Welcome to Livestreams. Thank you for joining. All right, my Georgian friend, Gamarjo Babijo, Otto, Raspergu. Yes, what's going to be talking today? The easiest way to know what's going to be topic for today is to follow me on Twitter. And always in the Twitter, I am announcing what the topic is going to be, what will be talking about. So that's all this information will be there. But hey, you know, it's a live streams. We're going to be talking about Confluent Cloud, maybe ksql, some other cool things. So it's going to be lots of fun. And if you missed the last episode also was blast. I failed with some of the tech. Didn't work out as I expected, but hey, it should work this time. It's much better. Hey, Sai, how's it going? So, Renan from Brazil. So, we do have India, Brazil, we have Georgia, Oklahoma City. Okay, makes sense. OKC, Oklahoma City. Now I learned. So, I'm also learning something during the during these live streams. And Rahul, welcome. Welcome. And do not forget, if you're here, subscribe to our Confluent YouTube channel. And you know, do some likes and stuff. Let's see how many. 17 people watching. 17 people watching. This is exciting. This is exciting. It's great to have everyone here. Yeah, let's chat a bit. Let's chat a bit about like things what we do. So like usually people just like super busy and just like, oh, let's jump in front of a gun and like do the stuff fairly quickly. So if you haven't been here, the last time where I was talking about the things around the Confluent Cloud and how we can use this with ksqlDB Java client, for example. And I did some work around this, and apparently the topic from previous week was very well received. I had many people reach out on Twitter, and we talk about some of the follow-ups. And something I want to show you. So after the previous week, after like our Tuesday stream, we went live on Wednesday with Sergey. He's one of the contributors to Project Reactor, and we played around with my implementation of ksqlDB Java client. And with this one, we also recorded live stream. So if you would be interested in this one and watching us like hacking around, it was longer session. It was more relaxed, and where we just like sitting there, like breaking things, and do not afraid to fail. And we're gonna be doing the same stuff tomorrow as well. So like it's gonna, if you have not enough of me and the live streams and things like that, You can also go to this link. This is a short link, and you can go and watch. Tomorrow is going to be another show. All right. So, yeah, let's do some questions. And Otto is asking if I can use Apache Kafka for real-time messaging tool. Like a messenger, for example. If yes, if it's a good idea to do it with Kafka. That's a very good question. And the answer is, as always, I learned this by doing some of the consultancy in the past, it depends. It depends on multiple things. General, Kafka can be used as a messaging tool. And as a matter of fact, this is how the Kafka came into many organizations. People start looking for replacement for traditional messaging systems, and because Kafka provides some cool features on optimizing, how to scale your brokers and things like that. So I think it's fair to assume that if you're using Kafka somehow you came in here with messaging in mind. So can you use it for real-time use cases? So for real-time use cases, and the reason why I'm asking and answering depends, it really depends on multiple things. For like a chat type of example, messaging type example, it definitely can be used, and you don't need to take care of things around like how to persist messages, because Kafka provides you persistency, and you can structure the messages the way how the putting some additional information. You can also applying some of filters along the way. You can also like pre-moderate some of the messages. You definitely can do this. Speaking about the real-time messaging, like if you're talking about very low latency, or like can you use Kafka for trading, for real-time trading? So it's a different kind of like approach and different way how you look at the things. With use cases like trading, where like latency is very important, maybe having the system that rely on a disk, maybe not something that you want to deal with. Maybe you will be good with some in-memory messaging system, or maybe not even distributed, because every time if you're talking about speed, you need to push the messages as fast as you can, but also will have some sort of like a buffer in order to services to communicate through. Maybe Kafka would be not a great fit, and it depends on what kind of numbers you're trying to achieve. If you're trying to achieve like seconds of latency or even milliseconds of latency, Kafka still will be fine. Kafka still will be a good choice. Kafka can be optimized for this type of loads. Kafka is highly optimized and designed to be, very heavy on reads. However, if you were talking about the nanosecond latencies and things like that, there are some better tools that can sort this. So it really depends on what kind of stuff you want to do this. So what is a good read and write speed for Kafka, Confluent Kafka cluster for Dev and Prod? So Vasim, I not quite understand this question. So what is a real good speed and write speed? It's all speeds are good as long as they fit in your SLA. Like it's as long as you fit in the numbers that you promised the business to deliver, it's a good speeds. So can you kindly elaborate your question? Hari from Chennai, welcome to Livestreams. Thank you for joining. Sai is asking, how does Kafka fits in data engineering? So Kafka fits in data engineering very nicely, I guess. And Kafka can be used as a pipe between multiple systems. So if you're doing some of the process, you can use the Kafka as a means to, system to exchange this data. This is how the Kafka actually came about on the early days, and the reason how the Kafka was developed is to participate in the faster Hadoop ingestion, for example. So yeah, the Kafka fits very well into data engineering. If you would be interested in this type of topic more detail, I highly recommend to look on some YouTube videos from Robin Moffat. So if you go to It's his website. He should have something around talks, presentations, and look something for like changing the face of ETL. So this is something for data engineers. This is something that data engineers will enjoy. I put this here, and we will put this link. I put this link in on the screen right now. So the you can this link will be available in the comments after you can find this, or you can always copy it from the screen here. It's a very good introduction into Kafka for data engineers. You probably will you definitely will enjoy this. So Hedge from Dhaka, Bangladesh. Welcome to Livestreams. That's awesome. If Kafka Stream store global over all instances of application, or it's maintained local to the instance. Okay, this is very specific questions straight away to start the conversation. So Kafka Streams state store global all instances of application, or it's maintained local to the instance. So in the Kafka Streams world, Kafka Streams provides a few flavors of state stores. One state store is partitioned. Essentially, you will have a partition. You will have a state store per partition, and each instance of your application might have its own instance. So it will be spread across instances. And when you start another instance, partitions would be served by another instance of the application, meaning that the Kafka stores will be available on other instances. There is a global key table that it's kind of like a replicated version of key table, and it can be shared across multiple instances of Kafka Streams applications. Not gonna go with details here, but it depends. There's Kafka Streams provides you with different flavors. Kafka versus connector. Hedge, I need you to elaborate this. I don't quite understand this question. Apart from adding more consumers to consumer group, do we have a consistent approach to overcome consumer lag issue? So I can assume that size, meaning that if consumer lag is growing, this is kind of issue for his use case, I guess. So let me see. Connect. Let me do this one real quick because the comment is not fit. Let me just okay. We can make it, and we can move it. Yep, like this, and we can do this like this, and like make it bigger. Yep, something like this. So growing consumer lag might be an issue in some use cases, meaning that you producing more messages that you can consume, but you need to figure out if it's really an issue for your use case. If it is an issue, you need to consumer lag. It is a good indication that something is going wrong. Like you need to find ways why it is the way it is, why you cannot consume faster, meaning that maybe you doing some other heavyweight stuff when you do consumption. So for example, you get the message, and after that you start like very long job, and in this case the message will not be committed until this job is done. Maybe you should approach this problem differently and use more like a synchronous approach. When you consume the message, acknowledge the message, and after that send the message through the pipeline and execute this. So I would rather suggest find the root cause of the problem rather than focusing on just blindly scale the things up, because you will find that it is, yes, you can adding more consumers in order to increase speed of read, but if you feel that this is kind of the problem there, or not the problem somewhere else. So I would rather start investigating what else you're doing during consumption. Maybe you're not committing too fast. Like when you read the message, you're not committing too fast. So that's why they stuck in this. They pile up them. All right. Yeah, it looks like today we have a very good, the Q&A session. Okay, folks. So, okay, next question. Let me see if I can do it smaller over here. Yep. Okay, and I'll do. Okay, something is not. All right, that's perfect. So, next question: how many partitions per topic, and what determines this? And how do I go about designing in this design? So there is very good. I already shared this multiple times. Like I cannot share this more. It is a blog post by Jun Rao. Number of partitions, and he goes in very deep details on how this can be done. There is a old blog post. So right now, if I go here, you can find his old blog post from 2015. But I highly recommend to look at the new blog post from 2018 when he was talking about what optimizations were done on Apache Kafka side in order to support that the higher number of partitions. So I will get these links here, so you can find this over here, also in the comments. And yeah, that's how you need to think about this. Okay, let me remove some of the nonsense that appeared here. So yeah, that's how you need to reason about this. But essentially, you need to think about many things. And June goes in the higher details about what means the having more partitions, what means that from perspective of application and from perspective of Kafka, from perspective of underlying operating system, how to handle this, like what's going to be number of I don't know, like file descriptors and how this will be affected here. So I highly recommend to start reading from this. And yeah, and my beautiful assistant Victoria is helping to put the links, and this is incredible that she's helping me with this one. All right. So, Victor, where we can expect a Kafka with Raft-based consensus implementation? It will completely work without ZooKeeper, and certain use cases still need ZooKeeper to sit up around. Last week, team. Let me find this. If we will go into. If we go to Apache Kafka Twitter, this is another Twitter that you probably want to follow is Apache Kafka Twitter. So in this Twitter, there's a tweet from last week where we talk about this this commit, this pull request. So this pull request actually lands initial implementation of metadata quorum. Raft-based. If you're in this type of jazz, you can go and look inside and see what was done. So you will enjoy reading this code, and it's part of Keep 595, and in the great details it's explained here. So when you will expect this to be released, I don't know, because developers are very bad on providing estimates. Work is happening right now. So it's engineers are working. You can follow work by signing up for mailing list and following this Keep 500, which is essentially, it is umbrella keep that includes some of the some of the architectural decisions. So rather than asking me this, I highly recommend you to start, reading this, because it has a great details of how this will be implemented. Let's go see. We'll put this here as well. So it's metadata forum. Oops, wrong one. We're doing this copy. And this is the pull request that includes this one. So yeah, that's you can find this in the comments afterwards. Now, so give me a second. Yep, it's working here, working back. Awesome. So, important question. What's your favorite movie? It's a good question. It's probably one of my favorite movies, Police Academy. A little unknown fact. Police Academy was awesome. And recently, actually, I watched a pretty good TV show. It's called Ted Lasso. I highly recommend everyone to watch it. It's very inspiring, and this is what we need in 2020. Thanks for this question, Rick. Thanks for your support. Now, it's a too specific question that will require some additional details. Is there any way to increase partitions per topic on the fly, more like auto-scalable systems? Currently, we'll have a change the properties from ZooKeeper and restart the properties from ZooKeeper and restart the cluster, which results in downtime. Oof. I don't know why you're doing this on the ZooKeeper side, though, because you should not do this in ZooKeeper. You should use the Kafka topic utility to change that. So this is a very good question. You see, you can do it today and without downtime. Yeah, probably I need to do. Maybe I should show you next time. Next time how it can be done with Confluent Server. It's pretty easy. All right, so let me switch and talk a little bit about something that I wanted to talk. You can continue with your questions. I'm really enjoying to answering those. Also, I wanna show you a quick something. So first of all, you're probably already familiar with this repository that has a bunch of cool things. And one of the things that I found that there is I personally found, my colleagues at the integration architecture team, they developed this pretty cool quick start. So what it does, it actually spin up like a full-blown environment, so I can play around. It spin up Kafka cluster. ksql. We already seen this in multiple times in this live stream, but I always wanted to play around with connectors. So, and I started looking how I can demonstrate this the connector type of jazz, and I found this quick start actually can provision some of the cool connectors. So what about we do this? So I will provision this in the cloud, and also at the end I will show you what I was working through the week, and I implemented this ksqlDB Java reactive client using a Reactor framework, project Reactor. So, and we'll see how this will work. So essentially, I already have this repository in my on my local machine. So as you might know, I prefer to run stuff on Google Cloud, so I will do start cloud. So essentially, if you found this example, it's on Confluent/examples, a great repository, and you will go to Confluent Cloud. There's a start cloud thing that will do everything, and also I'm changing the ways how I'm running this, and I'm running this in GCP. So let it see it, let it run. It will be executing. Yes, I want to do that. Yes, I know I have to pay for this. And if you're interested to do this type of things as well, ping me in my Twitter as always, and send me DM, and I will send you some of the coupon code. So while it is running, I would like to continue to answer some of the questions. Okay, so question is, after producer receives a schema from the schema registry during serialization, does producer serialize schema ID too? Producer serialize, producer receives schema from schema registry. Okay. During serialization, does producer serialize schema ID too? So essentially, schema ID goes as a part of payload of the message. So the next time when the deserializer will read the payload, it will read this like magical byte first and retrieve the schema ID, and after that pull the schema from schema registry. So this is how it works. So in this case, the schema ID needs to present in the payload in order to deserializer to retrieve the schema as well. So if yes, does consumer deserialize schema in order to request schema from registry to get schema for deserialization? This is exactly how it happens. So the part of the payload will have a schema ID. Schema ID will be used to retrieve schema from schema registry. So you're absolutely right, Sai. Is there improvement proposal on Kafka streams header before writing to Kafka topic? Vindia, I'm sorry, how it's spelled? Windhaya? Vin, need more information about this because I'm not quite understand what you're trying to say. There's a bunch of improvement proposals and relates to Kafka streams and headers. What exactly you implying? How does SAMS integrate into Kafka? Does Streams IP do not do what SAMS does? I have no idea because I didn't have a very little experience with SAMS. SAMS is another stream processing framework that also developed in LinkedIn. And I can imagine that SAMS has a similarities with things like Kafka streams. Though Kafka streams came after, like well after. So yeah, probably it integrates because SAMSA was developed by the same team or like at least a group of people. They were both involved in the Kafka and SAMSA. So I assume there's very easy to integrate with Kafka. So while we're doing this, and while I have a rig here online, I want to show something. So something cool that our team released last week while we were away. I mean, like we didn't do anything during the live streams, but this was something that we started working on, the thing called kafka-devops, which is kind of it's a attempt to eat our own dog food and essentially develop a set not only like written practices or like some of the recommendations, but actually have some sort of like repository that people can take and try to run themselves. Essentially, it allows you to see what's the recommended way to run Kafka streams, ksql connectors in Kubernetes, where some of the bits of your infrastructure, like a Kafka server, runs in the cloud. So I highly recommend you to check this out. This is very great blog post written by Rick. He's in the comments. You can ask him some questions here. Plus, it is very good. Where is it? A repository of the things. So if you didn't know, like in this repository, or if you didn't know anything about GitOps and how to develop some sort of like a workflow when you can change something in your infrastructure, and after that some automated ways will pick it up and make it happen. So GitOps is the way how to do it. It's like Git is your repository of the things, and the stuff will be storing inside the Git. Based on the changes on the Git, there would be some sort of robot or bot or chat or whatever that will make it happen. So highly recommend to take a look for people who are looking for the ways to improve this. And we probably will talk about this in the future. I didn't plan to do this today, but like I just wanted to highlight this. It's pretty cool. All right, so we do have an internal chat here, so which is great. So, couple things. We just successfully provisioned Confluent Cloud cluster. And today, let's see. Come on, where's my passwords? Passwords. Come on, one password. Doesn't work. Broke all the things. Where's my cloud account? Let me refresh screen. My my one password doesn't show up for some reasons. I don't know. Like, and it doesn't show me the. Yeah. Okay. So we go in this, and we go in this one. Okay. Meanwhile, I see we have 26 people and only 8 likes. Folks, we can do better. Just hit that like button, smash it like ding. Now, so we do have one cluster that just we created live. It's created in GCP as always. It's my perfect place that I like to run. Now, let's see what do we have here now. So we successfully executed cluster. We created cluster. We do have configurations that we can use. Now, we have ksqlDB cluster starting up. So we're waiting for ksqlDB to start. And after that, we will be able to do, let's see if it's provisioning or it's already running. Let's refresh it. It's up. Okay. So ksqlDB is up. And now we're going into validation phase. Schema Registry is up. Now we're creating some of the topics, and now this is cool part. This is where we bring in connectors. So many of you know, but you can bring some of the cool things into your Kafka cluster. For example, you can integrate with some like Amazon messaging system like Kinesis. You can join like the other things, but today, I would like to show you a Datagen connector. So Datagen connector, it's the connector that generates data, some of the fake data, but it easily allows you to start and see some data in your topic. So essentially, there would be 2 instances of the connectors that we'll be using. Oh, failed. Wow. I hope we will be able to recover. Hopefully. We'll see if Cloud will recover afterwards. Unexpected error. And this is generally live streams. This is what happens because like I run the script right before this and it worked. I don't know what is happening. We'll see if we will be able to start at least one of the connectors. I just need to show you some data is flowing here and that I can use things like ksqlDB to process it. All right, so I guess it's recovered thanks to the cloud, right? Once it failed, and after that it recovered. The cloud is awesome. All right, so what is going on in the chat? So we have some ZooKeeper discussion. So file stream now provided only for development and testing purposes. Windha, can you put more details about this? What connector are we talking about? Is it connector like a file connector that comes with Apache Kafka? It always was for development and testing purposes. It was there for just solid purpose of just like play around with bit. This one. Renan is asking, what's the difference between Kafka Streams and Apache Flink? Is there a recommendation for when to use each one and other? Well, so there are systems quite mature, probably Flink's even like more feature rich, and there's like a lot of cool things available Flink. I guess the main difference is just in architecture, because Flink requires you to run your application in kind of like a clustered mode, where Kafka Streams can be just a library. It's a part of your application, and so there's not much how you can, not much how Kafka Streams can dictate what kind of stuff, how you will provision it. But with this, Flink requires you like have a cluster, submit jobs there. There's also option to use Flink as a library. What's the recommendation? I don't know. What's your team team experience? If team have a more experience with Flink, you probably want to use Flink. If your team has more experience with Kafka Streams, you probably can use Kafka Streams. I'm not a huge fan on kind of like, oh, here's a table of like check marks where you go there and there and there, and after that you select like whoever has more check marks. I'm more on how it's called, holistic approach. I don't know. So I'm a huge proponent of the approach where you try it yourself. So you try you outline your business task, what do you want to do, and try to solve it with the two different ways, and you see how you feel about this. Like if you feel that you're more productive with doing the Flink, you go with Flink. If you feel you're more productive and moving faster with Kafka Streams, you go in with Kafka Streams. This is just my general recommendation around these things, not necessarily in regards to Flink and Kafka Streams, but also in any other, yeah. Okay, let's see. Now, we see that this demo is also provided us with some of the predefined Kafka Streams things here. Not Kafka Streams, sorry, ksql. So, and the cool thing is that if I will go to my UI and I will see ksqlDB, and I'll see a bunch of stuff is running here. Now, I want to connect to this application from my Java side of things and see if I will be able to retrieve some useful information. Now, enter to my welcome. Let me introduce you to my little friend. So I took the thing that I promised you last time, and I implemented this small wrapper around ksqlDB client that uses Project Reactor API, and let's see how it works, and let's see what we can do here. It's just like a live streams demo, right? Add to give public static void main. Oh, public static void main. No, public static void main. Yes. So what are we going to be doing here? So first of all, we need to connect to our ksqlDB in the cloud, env delta, and I need to do env. So this is our two things that we need to use. Up and up. And after that, I'll just do it like this. Now, if I'll do this one, create the configuration, environment variables, and just because I like to use environment variables. Now, ksqlDB cloud. So there's a couple things. We have this environment variable with endpoint, and we have this environment variable exception to message signature, and we have another one that has a user info. So in order to connect to our cloud cluster in the cloud, I need to do need to get URL, and I need to get the username and password. So now I need to connect here, And when I do a Reactor client from over here, where's my public static void main? Reactor client dot from options and the client options, and let's call it client. Now we will be able to do cool things. The last time I wanted to show how we can do like a cool things with the method chaining type of thing. So if we'll do list streams, then let's do log. We see this after that. Let's do then. I will do client dot list tables, and then I also let's do log. We'll do then client. We have a list streams, list of tables, and let's do list of what? Let's topics. Let's do log, and let's do subscribe. And let's run it. Let's see if it works. It's compiling. Now, let's do an indentation really quick. So we have this, and after that we do this, and we'll do this one, and we'll do log, something like this. So we have three methods, yeah, like this. So first of all, we get a list of streams, and our streams here returning the information. Sorry, not the streams. Streams info. So streams info object contains information about stream. Have a name. I have a topic name, like a real topic name. As you can see, stream name and the topic name are different. And this is something that information that gets from the ksqlDB server versus information that we're getting from where is it? That we're getting from. Yeah, that's name the topics that were created by ksqlDB. Now, also I see the format. It's format in Avro. I can get and interrogate individual streams here. So I have a table of users, table of that includes some information about users. So what we can do here? So once we've done this, let's. It's a very nice way to see like if it works. What was the problem previously? The problem previously was just the API was too verbose. If I will do say list of streams, it returns me completable future. In this case, I need to either wait until I assign the callback and waiting until this future will be executed, and after that execute another method. The mono from Project Reactor gives me this nice method that allows me to just like do then. So in this case, I can chain all these commands. So let's do something like create a stream query from beginning, and we'll do let's see if we can get all these users from subscribe, and we get a row. And what we can do with here, why it's so slow? Because I'm running the stream here. And I'll do row and some of the information of available column names. You know what? What I can do here, just like simply use stream from beginning and do log to simply show you what is going on here. And I'll do subscribe. So we will see what kind of data we have in a user table, right? So this is my application. This is how I connect into the cluster. I don't not necessarily need to have it here, but region, and I'll just do apps. Hey. Can I? No, I'm doing something wrong. Write down in the comments if you know how I can do, yeah, like this. And I'll just do, so yeah, something like this. So in this case, I will not show this on the screen. Now, this is how I connect to my ksqlDB, and I should get the data that comes from this. So my columns should be ID, register time, user ID, region, and gender. So essentially, I should be able to see same data that will come from this topic. And the data in this topic will be generated by the connector. And as you can see, it shows the way how it looks Avro, you know, if you will like write down manually. This is how Avro looks like. Now, this is how we see it that it comes in our application. So now it goes into, you know, full-blown Java object, and we can see what's the type of the object, what's the values, and things like that. So these are our values. It's a user ID, a timestamp, what's the ID, register time, user ID, region ID, and gender. So this is how we can get this from our application. So this allows us to do some cool things that we probably will do like next time. The things like maybe integrating this type of thing, integrating this code into like Spring Boot application that will be, you know, push this data back. Okay. Let me see the comments. There's some cool conversations going on. I see message retracted. I hope you folks are not being very unkind to each other. Hopefully you were not retracted just because you were agree with your opponent and you decide not to proceed the conversation. All right. Let's get back to this demo. Yes, once again, let's take a look what else we can do here. So we do have everything for our data engineering, for our data environment. So we do have a bunch of topics, and there are a bunch of say ksqlDB jobs that running here and writing data in. So for example, so page views. This is a source topic that is this is a producer that comes from a connector, writes data in the page view topic, and after that, this would be consumed by what? Page views females consumer. So let's take a look on this one. So where is it? We go in here, and this is how the flow looks like. It's another cool feature of Confluent Cloud that you can, as you can see, for so data flow. It's more like a low level. It shows you what producers and consumers. In ksqlDB here, it is a flow graph that shows how your streams and tables actually intersect. So we have a two user table and page views. We have a stream that will be enriched version of this. So let's take a look on this one. Can we take a look on this one? Yeah, and we have a definition how this stream was created. So when you're trying to investigate what is going on here, it's extremely helpful. In my opinion, it's super cool that its feature is there in the cloud available to you. So you do, we want to get information about only females page views. So in this case, we filtering by gender. So we're doing left join with the page use user ID and user ID, and we're also saying like if the gender equals female. So if I will go and do, for example, select from what's the page views female, I will be able to do from like this and restart. Kill it. And now it is a stream, and the data is flowing through. So again, as a reminder, there's two connectors that working right now, two instances of connecting that working right now. They pumping data, one data about users, and one data is about the page use. This is what the stream we get. And after that, let's see what we do have materialized here, where we're saying, okay, so page view regions where count is more than 1. And this is the example of tumbling window. We will show numbers. Let's take a look. So we do, I can also see what is going on here. Page view regions, so restart this. So couple things. So once we created this, in this case, it will create a table that will include gender, region ID, number of users, plus it should include information about the window, when the window starts, when the window ends, and things like that. Take some time because, like, I guess it's the new window will appear every 30 seconds. And the result will be here. So we do have columns, window start, number of users, and the value is based on region. Every, where is it? 30 seconds, it will be rolling the window. So it is pretty cool. So I highly recommend to take a look at this one yourself. Again, if you're interested in getting more credits for a cloud, let me know. I can throw you some of the things. Let's see. We'll do this one. And we'll restart. So in this case, we will have some of the stream that will include data from page views, but also will include some of the, what is it? Where is it from? Where split page view, female is page views, integer. So someone who can read more than 50 pages. So we will get the user IDs for these users, and yep, that's how it works. Where you can find this? So I think I will be starting putting some examples on like a separate GitHub repository specifically for Reactor. If you're interested in this Reactor client, you're going to Reactor ksqlDB. Right now, there's not much documentation. I just started the hack around 2 weeks ago, and we'll continue to work on this one. The cool thing is that like the test code here, many of you seen this last week, some of you maybe did not, but I use test containers to test my ksqlDB client. So in this case, you can also take a look at how it can be done. So essentially, my Livestreams demo right now is connected to my ksqlDB cluster in the cloud, but local cluster. So if I will do this testing, it will run against my containerized ksqlDB server, and it works like a charm. So in this case, when I'm creating the, so in this case, I can do I don't need to do this one from options. And here I go. I just refactored some of my code. Now, so if I will run this, it uses the test containers. It uses local Docker containers. This is for my Kafka server, for my Schema Registry in my ksqlDB. The initial startup time takes some time, but once it's done, the tests are super fast. And the cool thing is that like same code can be used to test around. So test in real environments. So there's a example how I can validate. It's this integration test that validates that stream was successfully created using the same APIs, basically, you know. So I'm execute statement, and after that I'm getting a list of streams. So this is why I know that my stream should be there. Different parameters of the stream should be there. Plus, also there's a very cool test that I'm testing here. Is where is it? The test that tests like some of the failures. For example, the Reactor project allowed me to do things like this. So when I trying to insert into the topic, into the stream, but the data or the stream was not created before, I will get the error. Now, and here I'm saying like if I will get the error, so retry this piece. Retry this until this would be retry this block, execute this one, and after that retry. So in this case, if this stream was not created, I will create a stream, and after that execute insert, and after that I will be able to do consume the data. Execute query from beginning is just like a very short version that essentially provides a map of properties that will read from the earliest offset. Sometimes it's useful. Let's do fixing here. I need to go ahead and fix in other places now. Yeah, that's small library. We'll continue to discover what is there in this library. Again, this is the GitHub. I will put this in my comments. Do not forget. Tomorrow I will have another live stream on my channel where I will be talking. We will be hacking around with test containers. So we'll continue to researching this. This project on reactive streams and Kafka and the ksqlDB, and we will see how we can like hack around some of the test container stuff. Now, let's see if we have any time for last question. In case you need to rekey a stream, why would we need to rekey, or rather do we rekey? Vasim, this is very complicated way to ask simple question. Why we need to do rekey? In order to perform operations like join, when we need to join some data from other topic, right now we need to collocate this data. So previously in Hadoop there was a way that called shuffle that allows to migrate data between different nodes in order this data land on the same node as the data that you want to join with. Same thing with the streams, but rekey allows to create new stream that will play around the stream through the stream where through the new stream where the key would be specified the way how it will be compliant with other stream. So if you do joins of the stream where your key stream IDs are not the same, you need to do rekey. Or you're changing the key of the stream, you're also doing rekey. So we need to do that. This is the important thing that needs to be done. All right. I think we did great. A quick recap what we did today. So we look into this one, CP Quick Start, which is a pretty awesome project. It's an example, but it's like it's an examples folder, but in my taste, it's a it's a full-blown project that allows you to simplify some of the runs. So I use this Confluent Cloud bit that allows me to run this. Second thing is that I showed you how I, modified some of the ksqlDB Java client, wrapped this in Reactor, Project Reactor API, where I successfully, connected to my cluster and execute some streams. Maybe tomorrow. Maybe next time I will show you how you can integrate with Spring Boot. Say like have a WebSocket server, and after that, data from ksqlDB cluster will be fed into this WebSocket server, and we'll see some data. Let me know in the comments how you like this idea. I remind you that my name is Viktor Gamov. I work as a developer advocate here at Confluent, and you are in the Confluent YouTube channel that you need to subscribe. Please subscribe, hit that like button. Oh yeah, we have more likes than I expected. We need a few more, and it makes my day. So I will waiting for you here in this channel next week, same time. Bring your questions, bring your family-in-law, bring everyone and watch the live streams. And as always, have a nice day. Stay safe and stay tuned for new live streams.